Finishing up section 5.5, we are going to look at the last three examples, and we're going to start off with the vocab term complex numbers. And a complex number is one that can be written in the form of a plus b times I, where a and b are real numbers and I is equal to the square root of -1. So underneath here, I have the complex numbers chart. So in the complex, in the gray area, we have a number added to something or subtracted with something that has I as the imaginary number. And then in the circles, we have real numbers. Real numbers are the numbers that you've always been working with. And then imaginary numbers are numbers that are that have I included or a negative square root. So putting those two together make a complex number. So there's a real number and then there's one with an imaginary number in it. So the real part is the A and the imaginary part is the B. So that first number out front is always going to be a regular normal number. And then the B part, the second part, is going to have an I or a negative square root in it. So for example 3, it says find the values of x and y that make the equation 3x minus 5i equals 6 minus 10yi true. So what we're going to do is actually break this up into two different equations. We are going to take the two real parts of this. So remember, this is A, and it would be a minus here, B, and this one is A minus B as well. So we're going to take the two A values, so the 3x and the 6, and set them equal to each other. So we would divide by 3 and have x is 2. And now we're going to do the same thing with the imaginary parts, only we're going to leave the i's out because they're the same on I is the same value on both sides. So we're going to have -5 equals -10y. So we are going to divide by that -10. And we're going to have y left here. And -5 over 10 would be 1/2. So x is 2 and y is 1/2. We're going to do that one more time here with this equation. So again, a plus b equals a minus b. So we are going to make the a's equal to each other. So we got -8 equals 5x. So I'm going to have to divide both sides by 5. So x equals -8 fifths. And then take the b's, the imaginary part, and we'd have 6y equals the square root of 6. So then I have to divide both sides by 6. So y equals the square root of 6 divided by 6. For example 4, they're asking us to find the zeros of each function. So we have to rewrite the equation so that it's equal to 0, so that f of x is now going to become 0. So we're going to have x squared minus 2x plus 5 equals 0. And then we're going to split it up. We're going to complete the square here. So x squared minus 2x plus something is going to equal -5 plus something. So we're moving that 5 to the other side, and then we have to figure out what the how to complete the square. And remember, completing the square, we have to add b over 2 to both sides. B over 2 squared, actually. And b in this case is -2. So -2 over 2 squared, so that would be -1 squared, so that would be a 1. So we're going to put a 1 in both of those spots. So simplified, we have x squared minus 2x plus 1. And then -5 plus 1 is -4. Now we have to factor. the x squared is x times x, and the 1 is 1 times 1. But since this is a negative 2 here, our 1's have to be negative. So it's x minus 1 squared equals negative 4. And then we're going to take the square root of both sides. So x minus 1 equals positive or negative square root of negative 4. And then we're going to add 1 to both sides. So x equals 1 plus or minus the square root of negative 4. And then we have to split that up. We have 1 plus or minus the square root of negative 4. That negative sign is the square root of negative 1, which is I. And then the square root of 4 is 2. So that simplifies down to 2i. So x equals 1 plus or minus 2i. Okay, so the same thing here. We're going to do x squared plus 10x plus 35 equals 0. And then we're going to subtract that 35 from both sides. Equals negative 35. And then we have to complete the square. And add it to both sides. So the b is 10. So we have 10 over 2 squared. 10 over 2 would be 5. 5 squared is 25. So we're going to add 25 to both sides. Negative 35 plus 25 would be left with a negative 10. Then we have to factor. And that is a plus 10. So we have x plus 5 squared equals negative 10, and then square root. So x plus 5 equals a positive or negative square root of negative 10. And we're going to subtract 5. So we're going to have negative 5 plus or minus square root of negative 10. And we have to simplify down that square root of negative 10. That would be a negative 1, so that would be an I. And the square root of 10 does not simplify down. So we are just going to write negative 5 plus or minus that I out front, and then keep the square root of 10. So x equals all of that. So all of it's pretty much the same as stuff that we've been doing, except for at the bottom we have to simplify out that imaginary number. All right, last part is the complex conjugate of any complex number. A plus bi is the complex number a minus bi. So basically, we are changing the sign in the middle. So the real number goes first. So let's switch this around first. The 15 is negative because it's a minus in front of it. The 2i is positive. Oops, I'm going to write 25. 2i. So now we just changed that plus sign in the middle. It started as this, and now it's negative. So negative 15 minus 2i. And that is your answer. So just make sure it's in the form of a plus bi first. This one, the I is your b value. So we don't have an a value, so it's actually 0. So it's 0 minus 4i. So we have to make that negative opposite, so it's going to be 0 plus 4i, and 0 plus 4i would just be 4i.